Hi, this session explores the foundational principles and practical applications of data warehousing, business intelligence, and information visualization. It details how organizations consolidate disparate data into unified repositories to enhance managerial decision-making and ops efficiency. Key technical concepts are addressed, including ETL processes, various system architectures like hub and spoke, and the evolving role of data lakes in the era of big data. Furthermore, the material emphasizes the importance of visual analytics and interactive dashboards in transforming complex datasets into actionable business insights. Real-world case studies illustrate how these technologies significantly improve performance, such as increasing fraud detection accuracy and maximizing customer acquisition. Overall, the session serves as a comprehensive guide to modern descriptive analytics and the infrastructure required to support data-driven organizations.
Every single year, governments are fighting this massive invisible heist. And I'm not talking about bank robberies. I'm talking about something way more widespread. Really sophisticated tax fraud based on identity theft. It is a huge, huge problem. So today, we're going to dig into how one state decided to fight back using a powerful and maybe unexpected weapon, a gigantic, super-organized library of data. And just to give you a sense of the scale here, let's just start with this number, $5.8 billion. Yeah, you heard that right. In just 1 year, that is how much money the IRS paid out for claims that it later found out were totally fraudulent. So we're not talking about a small problem here. We're talking about a multi-billion-dollar challenge. So how do you even begin to tackle a problem that huge? Well, to figure that out, we're going to zoom in on a specific case, the state of Maryland's battle against tax fraud. They were losing millions, and they desperately needed a better way to stop what their own comptroller called a systematic burglary of the taxpayers' money. So here's what the old way looked like. And spoiler alert, it wasn't working. Each year, their software would flag about 110,000 tax returns as being suspicious. But here's the catch. After investigators spent tons of time and energy looking into them, only 10%, just 1 out of 10, were actually fraudulent. Basically, they were casting this enormous net and catching almost nothing. And this is where it gets really frustrating, because that inefficiency had a real-world human cost. Every single year, almost 100,000 innocent people who did everything right, got their tax refunds held up. As one official put it, the thought that we were holding up 90,000 to 100,000 tax refunds was tough to stomach. I mean, you can imagine. So, Maryland knew they needed a totally new approach, a powerful new weapon that could see the entire forest, not just the individual trees. So they built what is, essentially, the ultimate data library. And it's called a data warehouse. Now, the official definition sounds pretty academic. A subject-oriented, integrated, time-variant, non-volatile collection of data. Okay, that is a mouthful, right? But here's the thing. Hidden inside that dense definition are the 4 secret ingredients that give this technology all its power. So let's break down what those 4 pillars actually mean. Okay, first up, it's subject-oriented. What does that even mean? Well, think of it this way. A normal, everyday database just tracks individual transactions, but a data warehouse organizes everything around a subject, like a specific taxpayer. This gives you a complete 360-degree view of that person, not just a random list of their filings. Second, it's integrated. And this is a huge deal. You see, state governments have data all over the place. W-2s are in one system, past tax returns are in another, property records are somewhere else entirely. A data warehouse pulls all that scattered information into one single place in one consistent format. It gets rid of those frustrating islands of data. Third, and this one is absolutely critical for catching criminals, it's time variant. It doesn't just show you a snapshot of what's happening right now, it keeps all the historical data. This lets you spot trends and patterns over time. For instance, you can easily see if a taxpayer's reported income suddenly and very suspiciously skyrockets from one year to the next. And the final piece of the puzzle, it's non-volatile. It's a fancy word, but the idea is super simple. Once data goes into the warehouse, it's there to stay. It gets locked in. It can't be changed or altered. It becomes a permanent, reliable record of the past, which is exactly what you need when you're building a trustworthy investigation. Okay, so we've got the what, we know the 4 key characteristics, but how does this whole thing actually work? I mean, how do you go from a total mess of raw data to this clean, organized library that can actually help you find the bad guys? So take a look at this. It gives you a great bird's eye view of the whole process. Over on the left, you've got all your different data sources. Old computer systems, web data, you name it. Then in the middle, that's where the magic happens. The data gets cleaned up and loaded into the main data warehouse. And finally, on the right, you see the end result, all the tools you can use for analysis, like dashboards and reports. Now, the real engine driving this whole thing is a process called ETL. It sounds technical, but it really just boils down to 3 simple steps. First, you extract the data from all its different sources. Second, you transform it, which just means cleaning it up and getting it all into one standard format. And finally, you load that clean data into the warehouse. Extract, transform, load. That's the core of the entire system. Now, that ETL process might sound straightforward, but believe me, this technology didn't just pop up overnight. It was actually born from a long struggle to make sense of these ever-growing mountains of data. If you rewind to the 70s, all the data was trapped in those islands on giant mainframe computers. Getting a unified view was basically impossible. Then in the 80s, we saw the first commercial attempts to build bridges between them. The 90s is when things really got serious, with pioneers like Bill Inmon laying down the blueprints for how this all should work. And that brings us to today, where this classic design is evolving to work alongside new big data technologies. It's a real story of constant innovation. All right, so that's the tech, that's the history, but what about the so what? Why does any of this actually matter? Well, let's circle all the way back to our case study in Maryland and see the real-world impact when they finally put this data warehouse into action. And the results, they were just jaw-dropping. Remember the old system? A 10% success rate at finding the fraudulent returns? Well, the new system, powered by the data warehouse, jumped to a 65% accuracy rate. It's not even in the same league. We're talking a night and day difference. Let me put that another way for you. This was a more than 6-fold improvement in their ability to pinpoint crime. They basically went from searching for a needle in a haystack to using a giant magnet to pull all the needles right out. And hey, don't just take my word for it. The person in charge, Maryland's comptroller Peter Franchot, said it best himself. The entire operation is getting better and stronger all the time. So the data warehouse didn't just solve a one-time problem. It created a system that could keep learning and improving its defenses. So in the end, Maryland used its historical data to solve a massive, incredibly expensive problem in the present. They stopped millions in fraud, and they sped up refunds for tens of thousands of honest citizens. And that really leaves us with one big question to think about. If this is what we can learn just by organizing our past data, what kinds of questions should we be asking about our future?